Why can't we always index a collection of sets with the natural numbers? Okay, first of all, before I answer this question, let's talk about what a collection of sets is. So a collection of sets you can think of as the same thing as a set of sets. That is to say, an example, in this case, an example of a finite collection of sets, is the following. The set of the sets maybe 0, 1, 1, 2, and maybe 1, 3. This is a set of sets, but I could also call this a collection of sets. But oftentimes we want to talk about a more general collection of sets. That is to say, a collection of sets that we don't know specifically, but we label as xi. And this collection of sets is all xi such that I is in some indexing set J, capital J, or sometimes you see an indexing set, usually you see an indexing set as capital I. And what they mean by that is this indexing set has a bunch of elements. So I is equal to a bunch of elements, maybe I, J, K, and so on, that specify the specific sets x sub I in this collection of sets. So this, if I were to expand this out, if I can expand this out, you'll see in some cases I cannot enumerate all sets in a collection of sets, especially if that collection of sets is uncountable, which that's an important fact that I'll talk about later in this video. But if I were to enumerate some of these sets, this would look like x sub I, x sub j, x sub k, and so on for I, j, k, etc., all in our indexing set I. So our indexing set is just a way to index, or that is specify, which x sub i's I'm talking about, or rather to identify each x sub I in this collection of open sets, or excuse me, collection of sets. But as I hinted to earlier, the answer to this question is why can't we always index a collection of sets with the natural numbers? Well, if I were to index a collection of sets with the natural numbers, say I did that with this x sub I example, x sub I such that I is in the natural numbers. This bolded in here is short for the natural numbers. That is 1, 2, 3, and so on. So if I were to index this set, well, if I were to index this collection of sets with the natural numbers, so then if I would expand this out, I would have x sub 1, x sub 2, and so on, x sub 3, and so on. But check this out. This only accounts for the possibility of me having a countably infinite number of sets x sub I. But what if I wanted to talk about an uncountably infinite collection of sets? What if I wanted to talk about an uncountably infinite collection of sets? So this way I index this collection of sets here, each of these specific sets, x1, x2, and so on, they're not necessarily distinct, but they're specifically labeled, they're identified by their index I in the natural numbers. This only is able to specify this way of indexing is only able to specify a countably infinite number of sets in a collection of sets. So let me clear the board here to talk about what I'm talking about and maybe give an example of why this is important. So when talking about compact sets, which is a topic we'll talk about extensively in future videos, we talk about open covers of a specific set. And what an open cover is let's say I have a collection of open sets G sub alpha. Then an open cover, and this is all alpha in our indexing set I. And I say that this collection of sets is this collection of open sets is an open cover for a set X. Then what I mean by that is X is contained in the union for all alpha and I. For every G alpha in this collection of open sets, X is contained in the union of all of these G alphas. So, what if I had the set 0, 1, that's a subset of the real numbers. This is all real numbers in between 0 and 1, not including 0 and 1. So, And consider the following open cover. Consider the following open cover. All open balls centered at each point x in the open interval 0 to 1. This is my open cover. I'll write this for short. All B sub x, all open balls, centered for each x in 0, 1. Well, check this out. Since there's an uncountably infinite number of elements in this open interval from 0 to 1, then there's definitely, of course, since each open ball is centered at each element in this open interval from 0 to 1, then there's an uncountably infinite number of open balls in this collection of open balls. That is to say, there is an uncountably infinite number of sets in this collection of open sets. So therefore, if I were to index this collection of sets with the natural numbers, say, if I were to index this bx, and I were to try to index them for x in the natural numbers, maybe starting from x equals 1 to n, or to infinity rather, because there's an infinite number, I would only be able to specify a countably infinite number of open balls. And this wouldn't capture the fact that this is an uncountably infinite number of open sets in this collection of open sets. And normally we wouldn't specify our indexing set as 0, 1 or some specific set. We would usually just say a general indexing set I that we assume to have enough elements. So we assume in this case the indexing set has to have an uncountably number. This indexing set to specify this collection of sets has to have an uncountable number of indices in our indexing set. But in general, we're going to have an indexing set I, and we assume that indexing set I has enough elements to specify every element in the collection of sets G sub I that we're trying to talk about. So it has this indexing set I has enough indices to specify every element in our collection of sets.